Our first question is, on frictionless floor, 1 Newton force is applied upon a toy car at 1 kg for 10 seconds. Thus, it has got 10 meter per second velocity and 1 meter per second square acceleration. The question is, number C, determine the traveling distance of the car in first 10 seconds. This is so easy question for you, I know. To solve this question, at first you have to write down what are given here. Okay, what are given here? What is given here? So given that time t equal 10 second and velocity after 10 second, the final velocity after 10 second will be 10 ms inverse 1 and acceleration was 1 meter per second square. All are given here. You don't need to calculate it yourself. They already calculated it for you. So question is, determine the traveling distance of the car in first 10 seconds. Okay, so A is equal what? So from the given quantity here, time, velocity, acceleration, and S, which of the uh, equation of motion is applicable for this given data? We know here we know we know the equation is equal ut plus half at square, half at square. With this equation we can solve this problem. So what is the initial velocity? Here initial velocity is 0 and time is 10 second plus 1 into uh, half into a is 1 meter per second square and time is 10 square equal 0 plus half into 1 into 100 equal 50 meter only. So after 10 second, the distance traveled by the body will be 50 meter only. This will be the answer. So easy. This one was so easy. And what is the second one? The second question is, after this event, will the kinetic energy of the car be changed? Okay, it's also an easy question for you, I know. Now we will solve the second one. This is the number C. This was the C, and D will be what is given here. Listen, the body move from rest position here. According to the stream, we know the body start from the rest position, and we know when the body was in rest position, the kinetic velocity will be 0. Okay, for the body when it start to move, for the body when it start to move, initial velocity was 0. Here initial velocity u equals 0. So kinetic energy for this case ek half m u square will be 0. Half into mass of that object is 1 kg and initial velocity is 0 square equal 0 joule. So kinetic energy is 0 joule for this case. And after 10 seconds, see the question here, velocity is given and acceleration also given. After 10 seconds, the velocity was 10 meter per second and the kinetic energy after 10 seconds. So now we will calculate kinetic energy after 10 seconds. So kinetic energy after 10 seconds. 10 seconds. Here V is 10 ms inverse 1 and mass is remains same 1 kg. Okay. So the kinetic energy after 10 seconds ek prime will be half mv square equal half into m1 into v is 10 here square equal half into 1 into 1000 equal 550 kilo, sorry, 50 joule. So kinetic energy is 50 joule here. So what is the change between the first one and the second one? The first, when it started move, the kinetic energy was only 0 joule, and after 10 seconds, the kinetic energy become 50 joule. So the kinetic energy changes 0 to 50 joule. That will be the answer. You have to explain it in word. Okay. And okay, this question is solved out. Now we will solve the second one. Second question. The second question. Okay, second question was, okay, see the first one, go through the first one, C and D again. Now we will solve the second one. Okay, now we will solve the second one. So I have to zoom it for our better. Okay, now number two, the question was about wavelength. We can see a transverse wave here, scenario 1 and scenario 2. In scenario 1, we can see for 2 lambda distance given 20 meter and velocity of wave is 15 meter per second in scenario 1. And scenario 2, a man has made a loud sound standing between two high walls 60-meter distance from each other. The distance of the man from first wall is 20 meter and the air temperature at that time was 28 degree Celsius. Okay, what is the question here? What is the question here? The question is number C. The question is here, number question C. Determine the frequency of wave presented in scenario 1. Okay, this also a easy question for you, I know. Here lambda is given, not directly given. For 2 lambda distance is given here, and the velocity of the wave also given here. So we easily calculate the frequency. Okay, here number 2, question number 2, I change my color for this pen. Okay, number 2 to C. Okay, what is given here? For 2 lambda, from the figure we know, we can see here for 2 lambda distance given 20 meter. So lambda will be 10 meter only, and velocity of that wave is 15 meter per second. Okay, and what is the frequency? And we know the most popular formula, V equal F lambda. Okay, so F equal V by lambda. So V, what is the value for V here? V is 15 and lambda is 10. So wavelength frequency will be 1.5 hertz. You must have to write down the unit. Otherwise, 1 mark will deduct from your answer. Okay, this is question number C, and the frequency will be 1.5 hertz. And what is the second question? That's mean question number D. Okay, D. Will the man of scenario 2 be able to hear echo then one echo, hear more than one echo? That's mean can he hear more than one echo or not? Okay, now we will figure it out. To solve this problem, I will draw it here with another color. Okay, magenta. Suppose there is a wall and there is another wall. There is another wall. Wall number 1, wall 1 and wall 2, wall 2. Okay, so a man standing between these two walls is standing here. Suppose this is the man. This is the man. Okay, this is the man, and he's produced a sound. What they say in the stream scenario 2, the stream is, a man has made a loud sound standing between two high walls 60-meter distance from each other. Okay, so the distance between these two walls is 60 meter. Okay, from here to here the distance is 60 meter. This distance is 60 meter. 60 meter. Okay, this is 60 meter, and the distance between first wall and the person was 20 meter. I hope, yes, 20 meter. 20 meter, right? Yes, 20 meter from the first wall. Distance between this person and the first wall is 20 meter only. 20 meter. Okay, 20 meter. And what will be the distance between the man and second wall? That will be 60 minus 20. That means 40 meter only. That will be 40 meter. Okay, so suppose when he make a sound, the sound go like this, and after reflection the light, sorry, after reflection the sound will come back to him, and that will be the echo, and this is the first echo. Let he can hear the first echo after t1 second, and sound also travel this side. Okay, and after reflection the sound will come back to him, and this will be the second echo. Let after t2 second he can hear the second echo. Let okay. So what is the velocity of sound here? That is not given here, and the temperature was given here. Okay, right? Yes, the temperature is 28 meter. So at first you have to calculate the velocity of sound on the temperature, because we know the temperature depends on, sorry, the sound depends on temperature. If if temperature is increased, the velocity of sound also increase, and this is the formula. Okay, so we have to calculate the sound first. Is it given here for 0 degree Celsius temperature? What is the velocity of sound? It is not given in your textbook. It is 330 meter per second. Okay, we know t theta by t naught here. Okay, here v naught is 330 meter per second, and it is the velocity of sound at 0 degree Celsius temperature. T naught is equal 273 Kelvin, and t theta equal 273 plus given temperature in Celsius, degree Celsius unit. Okay, what will be the sum of these two number? Okay, 273 plus 228 equal 301. 301. T theta is 301 Kelvin, and V theta we have to calculate it. That means at 20 degree Celsius temperature, the velocity of sound is V theta. Okay, so put the value here. Put the value here. Equal 330 into 301 divided 273, and the value after calculating this value 330 into whole root 301 divided 273, that will be 346.51 meter per second. This will be the velocity at 28 degree Celsius temperature. This is the velocity of sound at 28 degree Celsius temperature. Okay, now we will calculate. Now we will calculate T1 and T2. Okay, we know for echo, we know for echo, suppose here D1 is 20 meter and D2 equal to 40 meter. D2 equal 40 meter. Okay, so in the first case T1, and we know 2D for echo, 2D1 equal V T1, and V is V theta here. Okay, V theta. Okay, so we also calculate the value of V theta here. Okay, so T1 equal 2 into D1. What is the value of D1? D1 is 20 meter here, and divide V theta, and V theta is 346 346 point 346.51, and the value will be 40 divide 346.51 equal 0.115114 second. Okay, this is the value of T1, and what is the value for T2? Okay, I will calculate it here. So similarly, T2 equal 2D1 divide V theta. Okay, so 2 into, sorry, D2 into, what is the value of D2 here? 40 divide V theta. V theta means 346.51. And what is the value of this one? 80 divide 346.51. So the value will be 0.231 second. Okay, and for both case T1 it also greater than 0.1, and T2 it also greater than 0.1. That means he can hear two echo. There are another things we have to calculate the time interval between these two echo. Del t will be T2 minus T1 equal, what is the value of T2 here? 0.231, and minus T1. T1 is 0.1154, and what is the value here? Minus 0.1154. That will be 0.11, 1 minute, 0.32 minus 0.1154. That will be 0.1146. And this is also greater than zero point 0.1. This is also greater than zero point 0.1. That's mean he can hear 2 echo. If the result less than zero point 0.1 here, if the result of t theta is less than zero point 0.1, then he cannot hear 2 echo. He can hear only 1 echo. Okay, and this is the answer for the second one. Okay.